Okay, in this video, we are going to continue with revision exercise 11.1, matrices, vectors and transformations, but we're mostly going to focus on vectors. You will find this on page 620 in the Namibian Ordinary Level Mathematics textbook, y equals mx plus c to success. Okay, now, I must just very briefly, just like I did with matrices, I just have to go quickly through vectors. And I must just point out a few things. It's usually just after matrices. Okay, here it is. Sorry. Okay. And as I said, I'm going to concentrate more on the way that they ask it, just showing you. Now, this is very, and I think in physical science you have it, that they talk about, they call it about a distance and a displacement. Now, a vector is like a displacement, okay, because it's not just having magnitude, it's also having direction, and that's why you indicate it with the arrow. So it's between A and B and must move in this direction. So a vector is having magnitude, that means a specific length, but it's also having a direction. Okay, and then just the notation, I make capital letters. I'm using just like I showed you with Loki. I use two capital letters that I just put next to each other. And then I must indicate. Or I can use a small letter and then usually I write it on the line there, which is underneath. It's actually bold printed. So if I write it, I must actually write it and underline it. Okay. So this is for me just important. So if you name it, you're just going to say KM and then usually we make an arrow on top. Then if we make this bars, this vertical bars, now it's not meaning the determinant, now it's meaning magnitude. And you find that magnitude. I'll show you now, I will now show you an example. You do it just by Pythagoras Theorem. That's very basic. Can I just also say this to you? Equal vectors, that is like, say it's a parallelogram, then AB will be equal to DC. Their magnitudes will be the same as well as their direction. Okay, and then I just put it equal. This is not equal, although they are parallel, but they are not equal. Okay, vectors which are opposite, can I just show? If say for example, they call this A in this direction, if I want to change that direction around, then I will call it negative A. So I'm just changing it to the opposite direction, and there I indicate it to you. And then usually they can also write it as a column vector. And can you remember I used my T? So the value of the horizontal movement is on top, the vertical is at the bottom. Okay, just very, very briefly through this very basics. So there I'm making just sure, and I think it will be an examination, very basic also. Just making sure if you can draw it and if you can name it. That's your two things. So if you look here, if I say, for example, and I'm just going to do one, DC. So it's DC. I make the arrow indicating it's a vector. And then if I look, it's free. Remember, this is to the negative. So it's -2, not 3. It's 3 down, and it's -3. So let's leave. Oh, it was not DC. It was actually CD. But this will now be interesting. The arrow was not down. If the arrow was down, it would have been this. But if it's CD, then it's going to be 2 and 3. And can you see what happens? It's like I just multiply this one with a negative to get there, if the direction change. Okay, so that is the two. They can ask you, but they can also ask you to draw it. I just want to see the drawing, because usually when they ask you to draw it, then usually some of the students, they don't know where to start. They will say to you, Miss, where do you start? You can start anywhere, as long as it fits. So if I want to draw AB, and I just start here, and I call this A, and then I just go 1, 2, and I go 1 down, and I call this B, and I take my ruler, I draw the line, I show the arrow, that will also be correct. You can start anywhere, just as long, and you can see actually that this two will be equal. This I'm not going to focus too much on this. I just very briefly want to run through a few things. Calculating the magnitude, this is very important. I said Pythagoras Theorem. So it's actually because you are forming, I must rather take red. Take red. Take a ruler. Okay. And then you must basically, just might get my pen correct, I must find AB. Now, can you see my 90 degrees? So I know this is 1, 2, 3, 4. This is 4. 1, 2, 3. And I just use Pythagoras Theorem. So AB squared will be equal to 4 squared plus 3 squared, but it's square. So to get that square away, I will just take the square root, and that's why there is a square root. That's 16 plus 9, and it will give me 25, and the square root of 25 will be 5. Okay, so make sure, and they indicate it by making this vertical bars. Okay, this is very basic. I don't want to focus on this. Operations, I want to just very quickly show you some of the operations of vectors. If you add, just remember, and I'm just showing you, if you add just the top and the bottom, I'll show you now on a sketch. And then always remember, where the one ends, start with the next one. And this is what I showed you there, but I will now come to more better explanation once. Okay, can I just show you this one? And I think this is a very good to do the explanation here. If I'm saying as a quadrilateral, simplify as a single vector. Now, because vectors is having direction, you must not think just of the length. You must think, if I say AB, and I'm going to show it here to you. If I say AB, and I say plus BC, and I say describe that movement also for me, you can say, I must basically go, and I must just start where I start and end where, because it was like this. But if I start there and I end there, AC, that movement will be the same. Not the magnitude, not the length, but the vectors will be the same because we started at the same point and we ended at the same point. Now, when I was teaching, I always said there was a story that there was a grass. Then they said to the students, they must not walk over the grass. They must go the corridors. They must walk there. But then I always said to them, yeah, I don't think it applies to the students, but if a teacher must quickly run to the office, she can go over the grass. But our movement, you are the student, you walk in red. I run over the grass because they call me at the office. Then our movements in terms of vectors will be exactly the same because we start at the same point and we end at the same point. And that's why in physical science we will say it's displacement. Okay, and this is very important because that's going to help you in the calculations. So you basically just going to say, okay, I'm going to do still another one. If it's AD, and then it's CB, yeah, it's AD, and DB, and this was your movement. I want to start where you start, and I want to end where you end, but I want to take a shorter movement. So I will start at A, and I will run directly to B. So my movement will be the same as your green movement in terms of vectors. Keep it in mind. Okay, and then subtraction, it's just like I did with matrices. I don't think that's very difficult. And then I want to more come to this one because this is the type of one that I will explain to you a little bit. And because I showed you enough that I think I can tackle an example. But I like working with a parallelogram, so I think this is a good one to maybe tackle. OABC is a part where OA is A, and they show you, and OB is B, and they show B. Express the following vectors in terms of A and B. BC. Okay, now where is BC? Now remember, This is a parallelogram. So this is exactly the same as this. So if this is A, then what will this one also be? A. If this is A, then this will also be A. If this is B, what will that one also be? B. Just really interesting. What will happen? I want to take another color. What color can I take? Green. If I change it around, then it will be negative A. Just keep it in mind. Okay, so they say BC. BC, that will just be A. Then they say OC. OC. Now this is me, the teacher, running over the grass. You may not. So find a long road. Your road, and it's always good to write it down. That's my road, OC. But your road will be from, you start where I start, and you will go up, and you end where I end. So it will be B plus A, or A plus B. And then BA, and I want to clean it a little bit, and then I'll write it in again. Where's BA? BA. Okay, BA. This is again my road. You get your own road, but you must start where I start and you must end. You cannot go over that. You cannot take my short road. So you will run like this. Do you agree? And you will run like this. Then we will start at the same point and we will end at the same point. But this direction is turned around, so it's minus B. So this will just be negative B plus A, and which is actually just A minus B. Easy. And then AB, where's AB? AB, and basically, you can just say negative A. Now you just change around. So this is negative A, and this is, I follow the positive row, plus B. And that's the answer. Okay, I showed you enough. There's more difficult ones. Now I must just show you multiplying a scalar, just like I did with matrices, just in front. And just remember that they will be parallel. They will be parallel, but not equal. Okay, I just want to show you still one thing. I want to show you position vectors. I just want to see if it's here. This is a very nice example, but I will do now this kind of example in my exercise. Just position vectors. I'm stopping here because I just want you to know what is position vectors. So position vectors, I put it here, is always from the origin. So it's OA, OD, OC. That's position vectors. Now, I want to show you this because sometimes you get this, but it's more for AS level that you will get this. Then I want to, and the displacement vector AB, it's not a position vector. It must start with an O, meaning origin, if it's a position vector. But if I want to write it as a position vector, I can. I must just, now look, and I'm going to indicate it with colors. This is AB. Where is it now? Where is it now? And this is AB. Okay, do you see this is AB? And I want to write it in terms of position. Now again, this is my movement. You find your movement. You will go from A to O. You must write the long way. And then from O to B. That is going to be your movement. Do you see there? So basically, you are going to say, and look what I write here. I say, my pen. AB, and that is going to be AO plus OB. But be careful. This is a position vector because it starts with O. This is not, but I can make it if I make it a minus. Do you see? So actually, if I want to put it in front, I can write it like this. Okay, so basically, if I'm looking at this one, I'm then going to say to myself, okay, and I want you to focus here. I'm taking the second one and I put a O in front, and I subtract the first one and I put a O in front. So any vector, if I ask you to write this as a position vector, you can just take the second one minus the first one. And there it is in terms of position vectors. Can I give you a last one? DC. And you're just going to take the second one and you're going to subtract the first one. Okay, and this is also very helpful in some examples. Okay, I just want to see, and then I'm going to do that exercise. Okay, I want to go to the examples. Okay. Now, if I look at these examples, I'm just going to look at A. This is the easy one. The points P and Q, do you see that, have coordinates this. Write PQ as a column vector. So I'm just going to say 4A, and the first one, and if I write it as a column vector, so it is this vector. Okay. Okay. And then it's going to be PQ. And now just look at your horizontal movement. It's 1, 2, 3, 4, 5, 6, 7, 8, because the arrow is going like this. So it's going to be 8. And it's just one up. Easy, easy stuff. Okay, and then second one. QR, and I'm giving you copy the grid and mark the point R. So you just first have to multiply it. So you are just going to say QR is equal to 2, -1 and 1, and that's going to be -2 and 2. Do you see? But you must start at Q. You must start at Q. Now where's Q? There is Q. And then I just go -2. There's the -2, and then I go 2. And I get the point there, and that's the point R. And copy the and mark the point R. And that's how you do it. So you just first did your multiplication, then start at Q, because they start with Q, and then just mark it. Then I'm going to do the last one. Okay, let's start with number B. Number 4, I think it was 4. Now just control quickly, bring it back. Yes, it was 4B. I think I wrote it already there. Okay. Now, I just read everything and I just fill it in. This is very important. So, in the diagram, OU, and I'm going to just take my pen, and it's going to help me. So, OU, and that will be U. Don't have to write it, I just want to show you. That's U. And then I have OV, let's make it green, and in this direction, and that will be V. Okay, now let's start. Now, they say, OK is 2/3 of, OK, it's 2/3 of UV, and it's just important that I write it in. So UK, it's UK, sorry, it's 2/3 of UV. Keep it in mind. Okay, up to there. And L is on OU, is L, so that OL is 3/4 of OU. But what is OU? That's U. So it means that this little part there is 3/4 of U. And then what will this little part here be? That if this is 3/4, 1 minus 3/4, that will be 1/4 U. Do you agree? Okay, because it must add up to 1. And now I start. Oh, and I forgot, M is the midpoint of KL. In the middle, there. Now they say, find the following in terms of U and V. Give your answer in the simplest form. LK. Now where is LK? I'm going to make it blue. There is LK. That's my road over the grass. You must find a road where you will start where I start and you end where. Now you can do this one. You run there, run, but the problem is you don't have this. Okay, so I think the best for you is that you go up and then up to there, and then you must find this one. Up, so it's there and there. But your problem is you have that little part, that's a quarter U, but you don't have this part. But you can find UV, and I think it's best that we start writing now. I can find UV. And what is UV? And this is my road. Your road will be from here back. So it's not positive U, but it's negative U. And then from O to V, and that's V. Okay, that is UV. But you know that UK, and I write it in, make it blue, UK is, and this is the statement I'm using here, UK. So UK, it's 2/3 of UV. And that's 2/3 of UV, and I substitute, it's minus U plus V, and it's just going to be negative 2/3 U plus 2/3 V. And it's like working with P and Q. I don't like it because I usually want to confuse the U and the V. Okay, but make sure you don't confuse that. Okay, that's UK. That's UK. But if I want LK, the one they look for. So LK, will I make it red? I think so. LK. Start where I start, end where I end. Find another road. So it's LU, and I like first writing down the path, the road. So plus, it's always plus UK. Because then I can look up and I can look, what do I have? Do I have LU? Yes, that's that quarter. Can you remember? Quarter U. Do I have UK? Yes, I have UK there. So it's minus 2/3 U plus 2/3 V. And now I'm just going to add my like terms. And now I must just look. This too is like. And if you're very tired or very stressed, then I think it's best just to use your calculator. 1 ABC 4 minus 2 ABC 3. And that gives me negative 5/12. Negative 5/12 U plus 2/3 V. So break it up in steps. First show your road and then start filling it in. And then you can also look up and still get some of that information. Okay, and now I'm going to end with OM. That's now my second one. And that's OM. Now let's first find OM. Oh, I have it. What color will I use? I can use yellow. Sometimes you don't just see it, so I think it's fine. OM. Now again, that's my short road. You find a long road. Now your road can maybe be O to L, you have that information there, and L to M. Just remember that LM is the half of LK. Do you agree? So basically, if I want to find OM, I can take the road. Where am I now? OL plus LM. Okay, and I think it's sometimes good that you just write for you here on the side and say that LM, you can always work on the side. LM is the half of what? LK. And you have LK. Do you see that? So you're just going to substitute it in and half, and then it's going to be minus 5 over 12 u, do you see that? Plus 2 over 3 v. I think it's best to do it on the side here first. And then you just multiply, it's just a half. So it's going to be 5 ABC 12 multiply. And it looks like negative 5 over 24, which is actually very obvious. But for so late in the evening, it's not so obvious. Okay, and that is going to be 2 over 6v, which can be 1/3. So it can be negative 5 over 24, do you agree? Plus 1/3 v. Okay, I can just move it a little bit that you can see better. Okay, so now I'm just going to start. Go on with my one. What is OL? OL was that 3/4 u. It's just algebra now. Plus LM, there I found LM, and it's going to be negative 5 over 24 u plus 1/3 v. And that's going to give me, oh, I forgot here, the u. Do you see that? Okay, so there, usually you will pick it up if you look for your like terms. And then I'm just going to say 3ABC 4 minus 5ABC 24. And let's hope, oh, it's good. The answer is correct. And it's going to be 13. Let's keep it white. It's going to be 13 over 24 u, and just that plus 1/3 v. So it's just a little bit of algebra, but please write first exactly the road, then start filling it in. And when you work, look up and see if you don't have already the information. Then also, please don't forget that you must start where I start, you must end where I end, but I take the short road and you just look for a longer road. Okay, this is now today, 12 November. Tomorrow is 13 November. I'm going to still do a chapter, but I will first load it tomorrow morning early, say by 5 o'clock, because I still believe that students need sleep before an examination.